Before we move into theory, I wanted to start with a simple image of a dog interacting with their environment. Something as natural as sniffing reflects complex biological processes involving the nervous system, emotional regulation, and learning. Today's presentation explores how biology shapes behavior and why understanding the body is essential when we're trying to understand the dog in front of us. Dog behavior is often discussed in terms of training methods or environment, but behavior doesn't happen in isolation. Every reaction a dog has is influenced by brain activity, hormonal systems, emotional state, and past learning experiences. But before we explore specific biological systems, it's helpful to consider why biology matters when discussing behavior. Emotional arousal influences how easily a dog can learn or make decisions, and research shows that pain, stress, or hormonal changes may significantly alter behavioral expression. This is why effective behavior plans begin with biological understanding rather than focusing on training techniques alone. So rather than viewing behavior through a single biological lens, it helps to think of behavioral biology as an interaction between multiple systems. The nervous system, the endocrine system, alongside environment, genetics, and learning history, all work together to shape how behavior is expressed. Emotional and motivational systems influence how dogs interpret experiences, often guiding behavior before conscious thinking occurs. Learning then changes neural pathways over time, meaning that each experience contributes to future behavioral responses. Understanding this interaction between biology and environment allows behavior practitioners to move beyond surface level training and address the underlying factors influencing behavior. Looking more closely at this framework, the nervous system is a useful place to begin. The nervous system allows dogs to process information from their environment and respond rapidly to what they perceive. Sensory inputs such as sights, sounds, and smells interpreted by the brain, which then guides behavioral responses. So before we even talk about training, we're really talking about how information moves through the body. The central nervous system, which includes the brain and spinal cord, supports thinking, learning, and emotional processing. The peripheral nervous system enables fast communication between the brain and body, allowing dogs to react quickly to changes in their surroundings. Emotional arousal and stress play an important role in how the nervous system functions. When arousal is high, behavior may become more reactive and emotionally driven, whereas calmer states allow learning systems to operate more effectively. Understanding the structure of the nervous system helps us see how behavior begins, but to really understand behavior problems, we need to look more closely at how the brain processes emotion. So far, we looked at how information moves through the nervous system. But behavior isn't shaped by processing alone. Emotion plays a central role in how dogs interpret their environment, influencing attention, decision-making, and behavioral responses. According to a Mills study from 2025 on psychobiological models of emotion, emotionally competent stimuli trigger coordinated responses across cognitive, physiological, and motivational systems, which then influence behavioral outcomes. Or in simple terms, emotion prepares the dog for action. Neuroimaging studies by Endix and McCloskey also suggest that dogs process emotional vocal signals using specialized brain regions, supporting the idea that behavior is shaped by underlying emotional and neural systems rather than conscious choice alone. The dog's emotional state influences attention, motivation, and learning capacity. When emotional arousal is balanced, dogs are more able to process information and engage with training. However, chronic stress or heightened emotional states can shift behavior towards faster, more reactive responses. Understanding the role of emotional processing helps behavior practitioners focus not only on behavior itself, but on the emotional experience driving that behavior. I'm not going to go through every element here, but the diagram highlights that emotion is not just a feeling, it's a whole body process that is shaping behavior. Because emotion influences attention and arousal, it also shapes how learning takes place. The brain doesn't learn in isolation, it learns through experiences that carry emotional meaning. So, learning is not just a behavioral process, it's a biological one. Experiences change neural pathways within the brain, making certain behaviors more likely to occur in the future. When behaviors lead to positive outcomes, these neural pathways strengthen, which is why reinforcement plays such an important role in training. Importantly, reinforcement increases the probability of behavior rather than guaranteeing it, as behavior is always influenced by emotional state, context, and individual biology. So let's just take that one more time. Reinforcement increases the probability of behavior rather than guaranteeing it. Emotional state continues to influence learning at this stage. Dogs that feel safe and regulated are more able to focus, process information, and adapt their behavior. In contrast, chronic stress or discomfort can interfere with learning efficiency and increase reactive responses. Understanding how learning changes the brain helps behavior practitioners design training strategies that align with natural biological processes. This image illustrates how repeated and reinforced experiences strengthen neural pathways in the brain, making certain behaviors more likely to occur over time because the brain tends to follow the pathways that have been used most successfully before. So up to now, we've mainly looked at rapid processes within the nervous system, how information is processed and how learning changes the brain. Alongside these fast signals, another system influences behavior more gradually, the endocrine system. Alongside the nervous system, the endocrine system plays an important role in shaping behavior through hormones released into the bloodstream. Unlike the rapid signals of the nervous system, hormonal effects tend to act more gradually, influencing arousal, stress responses, energy levels, and social behavior. This is one reason behavioral change rarely happens instantly. Biology often moves more slowly than learning. The nervous and endocrine systems work together to regulate emotional and behavioral responses. Hormonal changes do not determine behavior on their own, but they can influence how behavior is expressed, which is why behavior practitioners should consider biological factors alongside training and environment. One of the clearest examples of how hormones influence behavior is the body's stress hormones. Stress hormones such as cortisol and adrenaline prepare the dog to respond to challenges, but they also affect attention, learning, and emotional regulation. Adrenaline increases arousal and supports rapid responses, while cortisol helps the body adapt to ongoing demands. In Cunningham's textbook of veterinary physiology, Klein describes how stress-related changes in cortisol can disrupt circadian rhythms, which may influence sleep patterns, an important factor when considering emotional regulation and learning capacity in dogs. In the short term, these systems are protective and necessary for survival. However, when stress becomes chronic, elevated arousal can interfere with learning, reduce behavioral flexibility, and increase reactive responses. For behavior practitioners, understanding hormones, the role of stress hormones helps explain why some dogs struggle to learn or regulate their behavior when they're experiencing prolonged stress or discomfort. This image illustrates that learning happens best when arousal is balanced. Too little activation or too low arousal, and the brain isn't engaged. Too much activation or high arousal, and the nervous system shifts into survival mode. Understanding this balance helps practitioners create environments where dogs can actually learn rather than simply react. While stress hormones often shape immediate behavioral responses, other hormonal systems influence behavior in a more gradual and subtle way. Gonadal and thyroid hormones can affect energy levels, social behavior, and emotional regulation, which is why they're important to consider when behavior changes seem unexpected or inconsistent. Physiological descriptions by Klein highlight how thyroid hormones regulate metabolism, energy balance, and nervous system function. From a behavioral perspective, changes in thyroid function may influence arousal, motivation, or emotional regulation, which is why behavior practitioners should always remain aware of underlying health factors when behavior changes appear gradual or unexplained. It is important to emphasize that hormones do not determine behavior on their own. Instead, they may influence how behavior is expressed in combination with learning history and environment. From a practical perspective, sudden, unexplained, or ongoing behavioral changes should always prompt consideration of possible medical factors, including endocrine health. All of these biological influences come together when we look at behavior from a practical perspective. Effective behavior management plans don't focus on training techniques alone. They consider the interaction of biology, environment, and learning history. The framework shown here highlights how behavior practitioners can approach cases systematically. First, we observe behavior carefully, looking at patterns and context. We then consider possible biological influences such as pain, medical conditions, neurological factors, or hormonal changes alongside learning history and environment before planning interventions. A study by Mills et al. From 2020 suggests that a significant proportion of behavior cases may involve underlying physical discomfort or physiological stress, which means that ruling out biological factors is an essential step in ethical behavior practice. Emotional state and arousal levels also influence how dogs learn, so behavior plans that prioritize regulation and welfare are often more effective than approaches focused solely on behavioral control. Ultimately, by integrating biology with environmental and learning considerations, behavior practitioners can create more humane, realistic, and sustainable behavior modification strategies. Building on this framework, one of the most important responsibilities of a behavior practitioner is to consider whether biological factors may be contributing to the behavior observed. Behavioral change is not always the result of learning history alone. It can also reflect pain, illness, or physiological stress. Sudden or unexplained behavioral changes are often a sign that medical factors should be considered. Collaboration with veterinary professionals support ethical decision-making and helps ensure that interventions truly address the dog's needs. By addressing biological factors alongside learning and environmental influences, behavior plans can better support both welfare and long-term behavioral outcomes. So, in summary, behavior is best understood as the outcome of interacting biological and environmental systems rather than a single cause. Sorry. The nervous and endocrine systems influence emotional state, arousal, and learning capacity, all of which shape behavioral responses. Hormones and physiology may affect how behavior is expressed, but they do not define behavior on their own. By considering biological factors alongside learning history and environment, behavior practitioners can develop more ethical, welfare focused interventions that support long term change. And ultimately, understanding biology allows us to see behavior not as a problem to fix, but as communication shaped by the dog's internal experience. And these are my references. Thank you for watching.